My name's Bill Robertson. I'm with the US Environmental Protection Agency, Region 9 in San Francisco, and you're probably wondering why I'm wearing a uniform. But believe it or not, EPA was formed in the 70s, and it was mainly public health service officers. So I'm a public health service officer assigned to the EPA. I'm also the coordinator for what we call the Oceania Regional Response Team, which is, it covers the area of American Samoa, Guam, Commonwealth of Northern Marianas Islands, and the Hawaiian Islands. And what I want to share with you today is our interest and our territory's state's interest in plastics and why it's significant in our interest in the Living Atlas and using the attribute data in there to form some decision-making, some answers to things. So plastic particle pollution, from our perspective, at EPA, we operate in the Superfund division, and I don't know how many of you are familiar with CERCLA. You heard of CERCLA? The Comprehensive Emergency Response Liability Act, Compensates Liability Act, and Clean Water Act. Heard of the Clean Water Act? And we operate under statutes and regulations. And in our group, in emergency response, we are obligated, by the way, we are on call 24/7, 365. We're responding all over the United States today. But we are obligated to respond to or consider responding to anything that impacts or threatens to impact public health, the environment, or welfare of the United States. And when Fukushima happened, if you remember that, in March of 2011, we became pretty concerned with debris in the Oceania region. And in our further work, we began to realize that it isn't the floating debris that's the real problem for us. It's really the microplastics in the water column. From our perspective, they are perceptually invisible, but they are numerically significant. I want to share some of that with you today. Anna Marie Cook started our marine debris program in 2011, and so these slides are representative of a lot of her work. So they are a priority concern for our states and territories, as I mentioned, and to some degree, if you consider the food webs and their impact on the food chain, we're concerned a bit with food security, as an example, especially sustainability. You've probably seen pictures like this of plastics around the world. Is this the middle button right here? Well, anyway, there are plastics everywhere, and I'm going to date myself for a second and put my bias on the table. But I started flying. I flew for the Navy for a career. I started flying around the Philippines and Indonesia and around parts of China and other places, and I was shocked at the amount of plastics in the water and the debris in the water back then, and it's only gotten worse. Part of our problem is what we think we know is that plastic production has increased probably almost exponentially over the years, and it's going to get even greater. We also think we know that recycling through our own programs at EPA, 5% maybe, recycling is a tough thing. It's not as popular as one thinks. But what's happened is we see these estimates all over the place about the science of plastics. And so what we hear but do not know, and we've heard this, is that by 2050, oceans could contain more plastics than fish by weight. Now, we know the person who made that estimate. I think she used some pretty good data, but we don't know. We also hear that 30% of plastic packaging escapes collection. Well, do we really know that? I don't think we do. So we apply at EPA what we call a risk assessment process. And for us, to simplify it, risk is essentially exposure times toxicity would equal risk in its weight. So we decide, well, what's the problem out here? And for us, the problem is we really don't know the nature and the extent and the fate of microplastics. We do know that they do soar persistent organics onto the plastic and can concentrate very, very, very high. And we also know that we've got a monk seal problem in the French Frigate Shoals area where monk seals are their blubbers and their blood are very high in polychlorinated biphenyls, and we're wondering where some of that comes from. This is just a quick slide on different types of plastics. Some of the main floating plastics are polyethylene and polypropylene, PVC not so much, but as you can see here, they do attract and hyperaccumulate, and they do bring things into the food chain, and I'll explain some of the fish tissue work and the stomach work we've done. So plastic particles, they tend to fragment into smaller particles. We look at plastics in the ocean as the largest oil spill constant in the world. We do clean up oil spills, that's one of our jobs. We look at this one, it's the same thing, it's just in a solid form. They are not inert. They really do sorb and hyperaccumulate. And as you all have seen, various things, fish, birds, mammals, they're ingesting this stuff, and it's not a good scene for fish and wildlife. In this whole risk assessment process, you have to characterize both exposure and effect, toxicity. And one thing we've learned fairly quickly is that there is no standard method for the identification of plastics. NOAA created a visual one with tweezers, and that's adequate for some degree, but when you start to get the smaller version, you really need a better methodology. So we're working on that. We've got some of the best forensic scientists in the state of California, probably the nation, working on building these methodologies for us. We hope to get ASTM standardization. Long story short, on the lab and analytical side, you've got difference in extraction and analysis for water column, for sediment, for fish tissue, fish stomachs. They're all different. And in the lab, it can be very expensive using FTIR and Raman to determine what's there. So we're working on the methodology and then also working on sensors. I wanted to show you just one slide. This is a myctophid. They can be about yay big. And we took myctophids from the South Atlantic and the North Pacific and analyzed them. And this, I don't know, where is the little speak? Anyway, you see that little fiber in there. That is a piece of polypropylene. And that was actually stuck in that myctophid's stomach. And so basically couldn't eat anything else. It was constipated with a piece of plastic. We're finding plastic in sport fish in Great Lakes in their stomachs. As I mentioned, we found both PCBs and plasticizers in the fish tissue of these myctophids from the Atlantic and the Pacific. Risk characterization, developing thresholds for this is going to be a tough thing to do. Would it be by polymer type? We don't know. But we do know that the more data we can gather, the more people doing information gathering, the better off we'll be in terms of trying to both determine thresholds and then maybe even come up with some fingerprinting. That's a tough role. You may have seen in the whole description of this presentation, Tern Island, and I bring this up because how many people have been to Tern Island? How many people know about Tern Island? Great, all right, man-made naval air refueling facility in World War II, given to the Coast Guard for a Loran station, and in 1979 they buried everything that wasn't useful, which meant they put all their PCB transformers underground. And that's a problem because the eels, as you can see here, are very high in PCBs. Monk seals are as well. NOAA uses this island. Anytime they've got a monk seal pup that's not quite doing well around the Hawaiian Islands, they'll put it in captivity, make it help it get healthy, and then they take it here to continue because there are fewer predators around Tern Island. It's also the only flat habitat for over 19 species of birds within Kauai and Laysan Island, which means it's incredibly important habitat for birds. So I was out there last summer, 2016, and I picked up some samples of sand, and that's just a typical sample of sand. I put a penny there so you could see the scale. There's a lot of plastics on the beach as well. We were petitioned by the Center for Biological Diversity, and you know what a petition is? It's sort of a, hey, we're going to sue you statement that said, we want you, EPA, to do a preliminary analysis of microplastics throughout the Northwest Hawaiian Chain, out through the extent of the exclusive economic zone. That's 200 miles out. We went back to them and said, well, you really should be doing this to Fish and Wildlife Service, but we'll take it, but we want to renegotiate with you. We just want to do the Tern Island area. And they said, okay. So Tern Island is our focus area for a lot of our plastics work. We are looking at exposure. We're working on building some sensors with some pretty unique engineering group. And we want to work with many of you if you're interested in it, and anyone else who wants to deploy. We're looking at open source. We want to get these sensors out there to try to get a better picture. We're looking at microplastics as what we've seen so far. We're looking mainly at the productivity zones in the oceans. That's where we plan to go. But we figure that much like air quality, we want to build a marine index for microplastics, especially in the productivity zone, so you have a better idea where the exposure is for what type of food web and maybe even food chain. We're working actually on wastewater standard. Wastewater operators are very interested in what's coming in and coming out of their facilities. Drinking water, of course, especially in the Great Lakes. We work very closely with the ocean dumping program. We've got some sediment work going on because we're finding microplastics in sea salt that you're buying. You're finding it in sand everywhere, and it's an issue. So for us, Living Atlas and ecological marine units, we'd like to work with various scientists like yourselves to determine the proper data elements. We've done a bunch of data quality objectives work, but I think establishing the proper data elements for the sensing and the extraction of information we're trying to pull together would be a really good thing to do collectively. And again, we want to fit within the framework if possible, and we're looking to you to see if there's any interest. And with that, happy microorganisms and happy zooplankton. Thank you.